Hello sir, I am Pranjal Tiwari. Today I'll be explaining some of the important aerodynamic concepts which will be later explained through simulation by my teammates Niranjan and Sumit. So what is aerodynamics? Aerodynamics is the study of how gases interacts with a moving object. Two of the most important forces to understand aerodynamics are drag and lift. Drag. Drag is the force air exerts against a car as it moves forward. Drag force is basically a vehicle's velocity squared multiplied by its drag coefficient and its frontal area. Drag is influenced by several other factors like a vehicle's shape, its surface roughness, and its boundary separation. Now let us take an example and consider a fast-moving non-aerodynamic brake. Here, air is going to pile up in the front, thus creating an area of high pressure. At the back, however, a low pressure air pocket forms, therefore creating a pressure differential. This pressure differential reduces the efficiency of the vehicle by pulling it backwards. Now moving ahead, what is lift? Lift is the perpendicular force exerted by the air on a vehicle. Lift is created by having a difference in air pressure between the top and the bottom of a car. Lift includes both positive lift, which helps in flying, and negative lift, that is downforce. To get the desired downforce, we tapped into a phenomenon called Bernoulli's principle. Bernoulli's principle states that a fast-moving fluid will have a lower pressure as compared to a slower-moving fluid. For example, a wing mounted on an F1 car generates downforce when air moves quickly across the bottom of the wing than it does across the top. This creates a region of lower pressure at the bottom and a region of higher pressure at the top. This helps the car to remain grounded even at higher speeds. This concludes my presentation. Now I would like Niranjan to proceed with the simulation of an F1 car.
Hello sir, this is Niranjan and I have done simulation of this F1 car. So I am going to show you the magnitudes of pressure in the different regions of this car. So to start with, the bumper of this car has pressure of 1.93 into 10 to the power minus 5 MPa. Now near the driver's seat it is 2 into 10 to the power minus 5 MPa. And as we know, on the upper side, that is above the car, the pressure is quite high. So the pressure is 6 into 10 to the power minus 6 MPa. And below the car, the pressure is low. So it is minus 2 into 10 to the power minus 5. So, and moving to the wings part, the pressure is minus 2.5 into 10 to the power minus 5. So I would like to explain this wing part in detail. So as you can see, the shape of the upper side of this wing is concave and the below side is convex. So in result, this creates a low pressure on the below side and high pressure on the above side. So this also results in creating negative lift and increased downforce, which helps the car in moving close to the ground. So by saying this, I'm concluding my part. The next simulation would be covered by Sumit Kulkarni. Thank you.
Hello sir, this is Sumit Kulkarni and I have done simulation for this minivan. Previously in the video you have seen simulation and the magnitude of pressure acting in different regions of a Formula 1 car. So in this video you will see pressure acting on minivan. At the front wheels or the front bumpers of the van, pressure is 9.84 into 10 to the power minus 5 megapascals. And on the front region of the windshield, pressure is 6.84 into 10 to the power minus 5 megapascals. But on the roof of the vehicle, the pressure is minus 8.15 into 10 to the power minus 5 megapascals. And also on the front wheels or below the front wheels, the pressure is comparatively low than the Formula 1 car is minus 1.11 into 10 to the power minus 4 megapascals. Due to this low pressure on the front wheels or the front side of this vehicle, it does not cause the vehicle to get lifted over as the Formula One car does. So this was our project, which was to compare two aerodynamic vehicles, and hence we conclude our project. Thank you.